Manufacturing Engineering as a Service Offering to Global Clients. Now, I request Ms. Bhavani Madam, Convener, Department of Mechanical Engineering, to welcome this session and to brief about our college.
Good evening, all of you. On behalf of New Prince Shri Bhavani College of Engineering and Technology, I welcome you all for today's webinar, Knowledge 4 Series, Manufacturing Engineering as a Service Offering to Global Clients. I welcome our Chairman, Vice Chairman, Director, Principal, all HOD members, faculty members, and participants for this webinar. I welcome our chief guests, Mr. C. Sundar Narayanan, Lead Consultant, Teams Private Limited, Chennai. Now I quickly take you through our college profile. Our college, New Prince Shri Bhavani College of Engineering and Technology, established in the year 2008, affiliated to Anna University and accredited by NAC and ISO 9001-2015 with excellent grade. This college provides you the best of technical education. We have successfully produced 91% placement in core companies like TCS, CTS, Wipro, Tech Mahindra, and Infosys during the academic year 2019-20. We provide enormous scholarship schemes for meritorious students by waiving off the tuition fees. We provide 100% free education to underprivileged and deserving students. I sincerely hope that this webinar will succeed in every aspect. I wish everyone here a good health. Thank you all.
Thank you, Madam. Thank you so much. I take this opportunity to brief about our resource person, Mr. C. Sundar Narayanan, Lead Consultant, Teams Private Limited. Mr. Sundar Narayanan has 17 plus years of experience in handling projects in new product design and manufacturing engineering arena. He has vast working experience with automotive highway vehicles and construction equipment clients across the multiple global locations from US, Japan, France, Romania, and Mexico. We welcome you, sir. I now hand over the session to sir.
Thank you, ma'am.
Thank you, sir.
Let me share my screen and please let me know if the screen is visible to all of you. Visible.
Okay. Yes, sir. Yes, sir.
Yeah, thank you. The topic for today is manufacturing engineering as a service, digital service offering to global clients in ER&D industry. That's what we are going to discuss in the next 1 hour time. I'll quickly take you through the agenda and the topics what we are going to discuss. To start with, to introduce myself, I am Sundar Narayanan. You can call me Sundar. I have 17 plus years of experience in new product development and manufacturing engineering areas. New product development in the sense of design, reverse engineering, and benchmarking kind of projects. In my initial days of the career, I have been in those projects. And the second half of my career was in manufacturing engineering services, in which I have coordinated a lot of projects in process planning, jigs and fixtures design, and I have personally done projects in digital validation of manufacturing plants and transferring plants from one location to another location, manufacturing facilities from one location to another location across the countries, even within the country and across the countries. In my exposure from a technology service giant, I had opportunity to work with the global customers who are located in America, Japan, Europe, and Mexico. And the digital manufacturing perspective, what I'm going to talk today is mainly from my exposure with the Japanese tier 1 customer, automotive customer, who has manufacturing facilities over 80 global locations, for whom we have worked in the production engineering center, coordinating their new line setup, any new lines they are bringing into the facility, and introducing any new product in the existing production line, or improving the current production line if there is a productivity improvement need to improve the current production line. These are the some areas where we have digitally validated and helped the customer to implement in the line. So I am going to mostly talk on the subjects around these topics today. So agenda for today, briefly what we are going to do is I'm going to just give an overview glance on what is ER&D industry, what is that business. Then next time, subsequently, I'll go to the product development life cycle, how a product is planned, developed, and how it is launched into the market. And then a quick overview of what is this manufacturing engineering, what we are talking of. The specific term manufacturing engineering, what are the scope area inside this term. And in that manufacturing engineering itself is a big ocean. And in that whole manufacturing engineering, we are going to see only today on the digital validation part, how digitally we are going to validate any process or a plant on that validation aspects. And after digital validation explanation, we are going to slightly touch upon the new topic that is talk of nowadays, the industry 4.0 or smart plant or smart manufacturing, what you might have heard that buzzwords here and there. We'll just briefly touch upon that, how this digital validation leads to I 4.0 will be the final slide. That's how we want to run today's presentation or today's discussion. ER&D industry, this word as such, what it means is engineering, research and development ecosystem. Wherever an organization has a design capability, or any global corporation who are putting up a design center in a country, or there are specifically engineering service providers who don't own a product but who just support OEM in digital engineering services, complete the research and development of new products and everything, or defense public sector units, or small and medium scale industries, and even some portion academics where there is research and development involved. This whole system is called ER&D industry, and the volume size wise, if you see, annual spend on this industry is about 1.4 trillion US dollar. It is going to be reaching in next 1 or 2 years. Right now we are about 1.2, I guess. That's volume of business that is happening in this particular industry right now in the world. And to talk about India, we are a pioneer kind of, since IT is also are one of the strong points. IT, this is IT enabled service. What the portion what we are seeing, ER&D is IT enabled service. This industry is also India's stake is almost about 30% in the overall industry spend. So close to about, we'll be reaching around 45 billion US dollar volume in business by 2022. That's the size of business what we are talking about, the industry that we are talking about. So IT enabled service business, this I have been in this business, in this kind of industry from my 2000s, 10 years before it started, that whenever before the Y2K, that was the buzz when the computers came too much into India. We started investing on IT related courses and engineering courses. So that's where it started. So in 1990s, if you see that business, there were global spending. There were people who were giving projects to India. So it was but piecemeal project. It was a contract engineer kind of project only. A company outside country will give a small project inside, 1 or 2 projects inside, and they will treat us as a contract engineer only for that specific project, only for that specific work it will be given. Most of the work at that time was AutoCAD only. In 90s, it was a 2D PDF drawing will be there. Legacy conversion projects, you will receive a PDF drawing, and you will convert that into AutoCAD drawing and then send them back. To some portion, there were some 3D modeling softwares where you model the product and send them. And slowly in 2000s, that changed a little bit into contract teams. Rather than 1 or 2 engineers, they started giving a bulk project in which a team of engineers sit and do the work and supply back to the customer. At this time, in the early 2000s, it was kind of software-based teams. When you go to IT service company and talk, they talked in terms of the software. They will say Pro-E team or CATIA team or SolidWorks team. They talk about in terms of software that was available in the market. And most of the work, what that came is from the US or any other customer location. you will receive the concept design. Concept would be carried out by the client engineer, and detailing the concept portion was in our scope at that time. We would create a detailed design based on the concept model, create a 2D drawing, and then send it back to customer. So when the size of these projects became bigger, there was a need for a coordinator to support from on-site or to work with the offshore teams. So we started sending senior engineers from our team to USA, Japan, or any country who are giving projects to us. And that's how that model started. On-site offshore model slowly started to come into IT engineering service business. Then in the late 2000s and early 2010, what happened was the on-site engineers are getting deputed for about 4 or 5 years. Slowly they became, the on-site engineers who are deputed there become a part of client team. They attend regular client calls, they attend regular client side meetings. So from which what started to happen is our Indian team started to get a product knowledge of what we are working on. For example, if a senior engineer is deputed at the automotive customer or a tractor vehicle development, off highway vehicle development customer, he started to participate in next model year. What are the changes that customer is working on? Who are our competitors? What is the strength of our product? Then what is the strength of competitor? Where competitor is weak? That kind of meetings were easily accessible for the on-site engineer. And he started to send that data captured, that knowledge captured to offshore team, and slowly started training the team on products. So at this time, what happened is, in the previous decade, it was a software based team. Now slowly it converted into client based teams. They started talking about, I am working for this customer, Honda team, Toyota team. The team's name will be in the name of customers most of the time. And software, even though it was important, software became little secondary because they were okay with any software, but the product knowledge gained precedence to all the software knowledge. So the project that we were starting to receive also went to a different aspect, little bit improved aspect, in which previously there were only concept designs which we had to detail. Now slowly we started to work together with the customer on the concept designs also. And de-featuring part, if there is a product developed for USA and you need to de-feature it for Indian operations, like AC is removed and instead of AC put a fan, and reduce the cost for that cab and reduce it and launch it for Indian market. That kind of project started to be coming on 2010. And in 2020, at this juncture, if you go back and see the type of industry, what is going on in the industry, we are the Indian service clients or any other service industry are being seen as a technology partner nowadays. So there are a lot of ODCs, offshore design centers, new product developments going on from our country itself. We are working with customers on joint patent, and there are a lot of strategic initiatives which the customer is telling us their strategy, what they want to become in next few years, and we join hands with them and work as a strategic partner with the customer to take them to the next level. I think somebody is raising the hand. If there is query, maybe shall we take it on the go, or shall we take it at the end of probably end of, I think Deepak or someone was raising the hand. Deepak, if there is a question, just to ping it in the chat window, we'll take it by end of the session. So we started working on digital, lot of digital technologies, and joint patents are nowadays being filed. Our companies, our Indian companies are working with customers to file patent jointly, co-authoring a patent. All these are happening. So this is how the industry has matured. By when we started this kind of projects, we started as just a detailing draftsman kind of people. But right now we are a value-added partner to our customers. That's how the industry has matured till date. And product development cycle. So we have seen how the industry has matured. Now, overall product development cycle, if you see, it starts from idea generation, market research, and understand the customer need, what the customer is expecting. And from that, generate idea, then generate a concept from the idea, few design concepts, and validate them. aesthetics, ergonomics, all that will come into picture. Then we'll go for detailed design. And when we go for detailed design, we will, this portion, what I am talking about is kind of manufacturing engineering area. We will think about whether our concept is manufacturable or not, what kind of material we need to give, and analysis, any other simulations, virtual testing, rapid prototyping, all these, realizing the project from a detailed design to realize and have it in the hand or send it to the customer. Until that area would be manufacturing engineering. So that's what we are, that's the area what we are going to talk about. And in that area specifically, we'll talk about digital manufacturing solutions. So manufacturing engineering as such, there was a famous saying, there's a famous saying usually, they say a manufacturing engineer is a person, what he says is, you can build anything once, but if you want more than that, you are going to need to listen to me. That's what a manufacturing engineer does. If you want to make more than anything, any of the product, you need to have a process, you need to have a method, you need to plan something. That is the manufacturing engineer's job. So in overall view, if you see what kind of typical jobs he'll be executing is, he or she, they'll be working with the design team at the end of the design phase or concurrent engineering phase to validate, design for excellence. They say design for manufacturing, design for assembly, design for quality, design for cost. All these comes into this DFX. So they validate the product for ease of manufacturability, plan the process, plan the tooling, plan the procedures to make it in the shop floor, plan the layout, how my plant should look like when it is being manufacturing the product, and plan the work cell, how my operator will stand, how his work location will be, and support them in the start of production, trial runs, proto building, and standard times, how many of the piece you want to build per month, and how to standardize the time for the worker who is doing the job, and warehousing, logistics, productivity, inventory reduction, cost control. All this will come under a manufacturing engineer's role. So if somebody says, if some company says they have a manufacturing engineering department, they'll be actively doing all of this work. That's where a manufacturing engineer's job lies. I'll go to the next slide. Industry wise, as such, the challenges that any industry faces nowadays, what happens to an industry that is running along with the competitor in this 2020. One thing, any new product development, you need to be the first one to launch it into the market. There is an idea that has come out of a market, and parallelly two companies are working towards it. The one who launches first will have a first mover advantage. So you need to have a shorter new product introduction times. That's a big advantage for any company. And manufacturing engineering plays a vital role to any company that wants to launch a product quickly into the market. Again, Rahul is raising that. Rahul, we'll take the questions at the end of the show. I'll just go through all the slides and then we'll take the question in the last end of session, please. So new product introduction in terms of design for manufacturing and assembly testing. And if you see in the market, when a new car, this was specifically made for automotive and off-highway industry, this slide, close to 200 DFM issues arises when a pilot program is being run after the design. When somebody is trying to make it in the shop floor, approximately 200 design for manufacturing issues will pop up. And to solve each issue, probably it will take around 1 lakh rupees cost, because it may call for a change in tooling, it may call for a change in methodology to work, or it may call for a change in design also sometimes, and which delays the new product launch time. So if you do a proper DFM, if you do a proper digital engineering and validation, you will be 20% quicker than your competitor to go into the market. That is one, launching a product. And when the product is launched, it's running successfully, when the plant is running, the next challenge a company faces is on the excessive capital and operational expenditure. How much people or how much resources you are putting into the factory to make the same piece. If my competitor is making the same piece by employing 10 people, and if I am employing 20 people to do the same, my cost advantage goes down. So that becomes a very critical portion, and that's where manufacturing engineer comes into picture to optimize your resources to make the product, the inventory, the tooling cost, and everything. So these are the two industry challenges where a manufacturing engineering team will help the customer to achieve the goal. I'll go through a service industry offering also. If any company says I am into manufacturing engineering, these will be the type of offerings they'll be giving. So I have put it in a sequence for you to understand easily. It is a kind of product life cycle, manufacturing engineering service spectrum, what we used to say. When the product design is getting finalized, you will have to do a DFX, design for manufacturing assembly. That portion you will have to work on. Then process planning will be there, bill of material verification, validation will be there, work instruction preparation for the operators to work on the product will be there. And once that is finalized, then you need to plan on, once the process planning is done, you need to plan on jigs, your fixtures, toolings, grippers, how we are going to make the product. The tool finalization need to be done. And when we talk about jigs and fixtures, concept design for the jigs and fixtures, then detailed design for them, drawing creation, all that will be a part of offering. Then comes your digital validation. In this, what we validate is if we are planning an assembly line, what is the sequence I am going to assemble that particular, for example, if I take a car, in what sequence do I have to assemble the car? Is my station 1 and station 2 and station 3 okay? How is my product, if it is okay to assemble in station 2 or 1? That kind of validation. And throughput simulation is the one, is my company as a whole will it be able to produce the volume what I am planning? That simulation and validation. And human simulation is if I am using a human being to work on that assembly line, if he does that job whole time for a whole year in his life, what kind of injuries or what kind of issues he is prone to have when he is working on the station. There are global standards. So if your design of the cell, work cell, should enable him to easily work without any issue in the station. So that's a human simulation analysis. And robo simulation is there might be multiple robots in a work cell, welding robot cells or any other robotic assembly cells. If there are multiple robots running, how they are working in between themselves to manufacture their product? Is there going to be any clash? Is there going to be any issue when multiple robots run in the same space? That validation will happen in digital manufacturing. And then comes your layout design. Layout design in the sense for the whole plant, number one, you need to think about material in to material out, how my factory is going to be, where am I going to bring the raw material in, how am I going to store it, and what is the number of crates or number of bins I'm going to move it into the line, what is my line side design, what is my work cell design, and what is my line side storage, how am I going to store the products in line side, and how am I going to rotate my empty bins and get it filled and bring it into the line, what kind of material handling equipments I'm going to have it, and how am I utilizing my whole space inside. That layout design is also one of the offering. Then comes if the factory started to run, if there is a factory already running, or if you are launching a factory, then comes a value stream, complete value stream of the factory, from where the product's value started to get captured till the end. How am I adding value to my product? Am I adding right value in the right cost? Then standards, work standards. For example, how many operators are needed to make this particular vehicle? And balancing of line. Are all the operators equally loaded in the line? If I'm using 20 people, are 20 people equally loaded? Or am I overloading 10 people and underloading 10 people? And lean manufacturing, basically it talks about reduction of micro wastes and optimization of all the resources in hand in the facility. And world-class manufacturing, a similar concept to lean manufacturing. These will also be an offering of a manufacturing engineering service industry. Then when it comes to warehouse, my raw material warehouse, my finished good warehouse, how am I planning? And containers, how am I shipping? If I'm shipping from India to any other country, what is my packaging plan? Am I loading my container properly? What is the utilization of my container? And how am I moving my material inside the warehouse and outside? Material handling equipment selection is another key area. And yard management, how many trucks are going to be parked in my facility at a given point of time? Am I utilizing the truck's time effectively? How many number of vehicles am I using to move the product between my supplier and my location, or between myself and my customers? all that optimization will come under logistics and warehouse. Then manufacturing support, of course, in the terms of deploying people in the shop floor to help the customer in factory acceptance testing, installation, prove out, start of production. All these overall spectrum is a manufacturing engineering spectrum. Each of the topic what I have put here, maybe we can discuss one day each in each of these topics, but today for the time sake we are going to specifically talk on this digital manufacturing, where you do validation, throughput simulation kind of projects to a global customer. That's where we are going now. Digital, when you talk about digital itself, digital is another inside manufacturing engineering. Digital itself is a big area and it's growing continuously also. If you see from 5-year gap, 2013, 18, 23 projection, the whole digital engineering pie, uh, uh, it was when the spend was 1 billion, around 1000 billion USD, digital was around 159 billions. It was 15% globally in 2013, and it became 25% spend in 2018. The same digital is going to be 37 to 40% spend in 2023. And if you see, the pie size is also getting bigger. The volume, industry volume is also going bigger, and digital is also expanding rapidly. That's the size of business what we are. So if a company is into digital business in the world right now, it is eyeing about 642 billion revenue. It is a part of 642 billion US dollar revenue in the world right now. That's the size of industry what we are talking. So as an industry, when someone is talking about digital engineering, these are the total areas that anybody will be talking on. The industry side, all the industries are in picture: automotive, aerospace, consumer goods, industrial, medical devices, software, telecom, high tech. All industry needs to do this. Number one, they need to renew their old factory into a new factory, incorporating all the digital solutions inside. That is, you need to bring robot inside. You need to do a digital product lifecycle management. You change all the your existing software in the plant to leverage the digital solutions that is available in the market. Then industry 4.0 is coming. You need to bring about sensors and other things into the factory. Digital twin is another concept. I'll slowly slightly touch up on this topic a little bit in the last slide. Then simulations are there, introduction of robots into the plant. All these are renewing old factories in that aspect. And when you build a new, everything that any future company, any new product development thinks upon is on the smart side. It should be autonomous vehicle, connected vehicle, ADAS, driver assistance systems, smart devices, whatever we are making it as a smart nowadays. Incorporating sensor, taking the data out and analyzing the data and giving feedback to the user on how to optimize their usage. So this is the industry, and in this portion, in the whole area what we are talking about right now, the next few slides that we are going to discuss is on this area, digital validation only. In the plant, when there is a digital simulation or validation, what kind of projects are we doing right now for the global customers? Any global industry, what project are they doing for the global customers? That's what we are going to see in the few slides, next few slides. Number one, animator work instruction. This what happens is in any factory you need to have a work instruction in the line for the operators to read and understand what are they making. Most of the times trainings would be given, but after the training is given, any new operator, when he goes into the line, he will be having questions on how to manufacture certain thing, and he will be taking support from team leaders or any other senior operators nearby on how to do that part, or he'll be given a document on how to manufacture also. He can quickly reference that, but most of the time he'll be taking support from seniors in the line. This particular offering that we do is whatever we were previously giving on photos and work instruction type of Excel format kind of work instruction, we move it into an animation right now. So this a 50 or 55-inch screen, I have personally seen this in countries like USA, where there is a critical operation, a TV screen will be installed on that station, and this kind of work instruction will be run in the TV continuously. So the operator will be regularly seeing the sequence of assembly, what kind of tool he has to use, what's the torque and how, in what sequence he'll be building the product. So that helps in any new operator for training also. And it is a need for one of the mandatory requirement of any lean manufacturing facility also, to have the work instruction in place for the operators or anyone to come and see what is happening and to understand what happens in the station. A typical digital work instruction animated will be looking like this. I'll run this animation so that you understand. So using a PLM 3D model itself, we can build this kind of animated work instruction, and we can display it in the shop floor so that the operators can understand what is my next step, and what kind of tool I can give the part name and everything. And we can also give what kind of tool we should use, and what is the quantity, and how much time it should take to assemble this product. All this kind of supplementary data an operator will need to assemble or work on the product will be given in an animated digital format, and this will be keep on running in the factory. So it becomes easy to anybody to understand the next step without disturbing the seniors. So the productivity automatically improves. The first time right quality of the product improves automatically in the plant. So this is one of the offerings. Nowadays, the companies are slowly moving towards this, many of the companies. This is what an animated work instruction will look like. So a process engineer should know what kind of sequence the product should follow, and he should incorporate that in a digital format and give back to the customer. This is one offering in digital. And next, validation side, ergonomic validation. What we saw in the manufacturing engineering spectrum, we saw on the digital validation part. This is one of that offering what any company does. Tools like Delmia, Technomatics, Jack, there are multiple tools available in the market to do this kind of ergonomic analysis. So there is, example, there is a line like this operator is working on a car assembly line in which he is fixing some seat or something in this station. So if he regularly does this job 8 hours a day for a year or for a continued period of time, what kind of issue he will be having in the body? Is the posture okay? Are we giving him the right tool to work on? So there are international standard analysis like RULA and REBA. RULA is rapid upper limb analysis. So mainly focusing on his shoulder and arm, how much stress will be there on his forearms and shoulders, like in this upper body area. And REBA is entire body analysis. This mainly focuses on his posture, how he is standing, how much he is bending. Is he prone to develop any issue in his back when he continuously does the job for a prolonged period of time? This analysis is a mandatory for any factory that is being installed. So what usually used to happen is previously these are all being done at client location at the site. Now since we have internet is very strong, very good now, so a lot of these things happening now, we can do it in India and give the feedback to the customer. So the client will send the whole 3D model, whole factory layout, whole 3D model. We'll bring the 3D model in, and this mannequin, what you are seeing, the human mannequin is, we will understand about to which country we are working on. So for each country, there is a different size of mannequin, or the customer will let us know what mannequin to use. How much height is my average employee's height, average worker's height, and we'll have to work on that. So this simulation, for example, is you see, so he's going to fasten the seat in the car body. That's the operation. So now you bring the mannequin inside and you assign the task to the mannequin. What kind of work he need to do? He need to bend and use the screwdriver or spanner to tighten the bolt there. So when he does that, when he does this kind of activity with his posture, with his for his height, where are the stress points? Where all he is going to be loaded? Is his shoulder going to be okay? Is his back going to be okay? All that validation will be done. And there are scores, specifically international scores available. 1 and 2, it is no risk. 3 and 4 is low risk. 5 and 6 is medium risk. 6 plus is a high risk. See, from the color coding, you will be able to know. The software will evaluate and tell us where the workers may be stressed, what kind of, if you see here the score, so wrist score is more, muscle score is more. So in all these areas, we need to check and work on. So the output of this validation is another thing is visibility check. This tool also evaluates, will he be able to see the location properly in his posture? Will he be able to visualize where he has to work on? How in from this angle, if he looks, will he be able to see this bolt itself at least? So that analysis also can be done. Once this is done, what the next step is, what is the outcome of, okay, we have done this analysis, we have analyzed and told the customer this is where these are the areas areas with the issue. So this will call for multiple things. One thing what happens is you may change the tool. You may feel that, okay, I'm not going to give him his hand wrench tool, I'll give him a power wrench or hydraulic this pneumatic operated guns for him to utilize. Step one, maybe. Or step two, maybe I'll change a different fixture. I'll increase the height of this whole vehicle so that it becomes easy for him to visualize and work on it. If none of this is possible, it may call for changing design also. Sometimes it will go back to the design team and say that, no, this issue is going to be a big issue when I completely do this vehicle in the line. So let us check out and see if there is a design change possible. Or is it possible to work on another station, previous station itself, where before the top comes in, will I be able to do this? This kind of analysis is done. So this is one of a key offering for, I have seen engineers working in the same field for about 5-10 years. This is one, looks like this is a one slide presentation, but this one slide is life for many of the people in the industry nowadays. So this is one, by using software, how to validate. The same validation with the advent of introduction of new sensors and technology in the market. If you see, there are other similar offerings also, like instead of bringing a 3D model inside and validating using a model, you attach sensors to the worker's body continuously and make him perform the job in the shop itself directly. And you capture where the stress points are. This is a quicker way to do, but this has to be done at on-site only at the location, directly in the factory. The previous one, what I did is completely digital. For a factory in USA, you can do it in India. But in this method, you have to be in the shop, in the location to do this. It may be costly because of the sensor and other software involved. And because of it is being done at on-site itself completely, it may be a costly solution, but it can be a very quicker solution, because the previous exercise what I saw, that can take about a week for one engineer to work and give a solution. But this may be probably in a day, somebody can evaluate and tell them. So if somebody is rushing you for a timeline, we can use this kind of technology to do an online analysis also. But most of the time in India nowadays, the previous slide is the one that is happening. I'll quickly show the video on this also, how the evaluation. See, when the operator is moving itself directly, the mannequin is getting evaluated on the stress points where he is, see the shoulder is highlighting, the back is highlighting. These are the areas he is getting stress. So from the score, what he is getting, from the risk rating, what he is getting, we'll be providing him with additional tools or additional things to work on, or change the work environment a little bit so that it accommodates, the work environment accommodates him easily. So this is on ergonomic validation. Basically, when a human being and a workstation interacts, how the validation happens. Next validation, what most of the industries are doing is this one. This is very critical. A lot of companies are doing, that is, many of the OEMs wish this kind of capability in any of the service provider. This is one niche segment also, in which a company, if there is a robo available, or if there is a complete robotic assembly line, you need to design on your robot, what kind of robot do we need, what kind of fixtures do we need, and you need to check reachability analysis further. Will the same kind of visibility and reachability analysis we did for a human being, we can also do for a robot. Will the robot arm be able to reach the location what we want to do? If it is welding, is the welding point reachable for the robot, or do we have to change the tool? So tool validation will happen, gripper validation will happen, simulating the robo. When there are multiple robo in the same station, are they going to clash with each other when the robo is running? So all this, when you know which robo or the customer is going to use and the robo model, you can do the offline programming in sitting in India itself, and you can ship the program to on-site, and in on-site only one engineer can load the program, run it and do a trial, and maybe do some online teaching and complete the whole project. So this is one example again. I think in most of the videos I took it from online, because many of these kind of videos are very confidential, sensitive information. So I may not be able to showcase what I'm directly doing in the company. So I looked for some similar videos online and have put. This is one Volvo assembly line, welding robot, probably. I think this is a welding robot. You can parallelly see the 3D analysis they have done and the real-time working also. This video is combining both. It will show the 3D visual validation also, and it will show the real-time, the same robots working on the line also. So this is one bigger area for people to work on. Manufacturing engineering services is a very critical area, and it's a niche segment. There are not many engineers available to work in body in white welding kind of robo analysis kind of projects. And even robo supplying companies also very few. ABB, Kuka, Magna, some few companies are there. So most of the bigger orders go to them, and they are always looking out for partners who can support them in this kind of projects. So here this company claims that using their product, 99% of Volvo's work is being done, validation. And this is another multi-cell robot where 3 or 4 robots are together working in the same cell. There is a fixture, and these guys are together welding the component. And here what will happen is you need to do a clash analysis. When 3 robots are welding together, are they going to hit each other when they are welding? So we have to plan the welding sequence in such a way that one robot does not interact with the other robot, or one robot does not clash with the other robot while doing its job. So this is a very important validation also, because it may look like a small thing, but when a clash happens, it will cost heavily if there is a clash between 2 robots. Cost wise also heavy, damage wise also it will be very heavy. So this is a robo simulation validation, one of the critical offering. So next, plant simulation. So whatever the previous 3-4 slides, whatever we were talking, were on one station, one process, interaction between man and a machine or machine and a machine. Now this plant simulation is another validation. What we want to do, this is on a whole plant level. From the bird's eye view, look at your plant, how the material is entering inside, how it jumps from station to station, machine to machine, how much time it spends on each machine, how much time it spends on a work in progress area, how much time it is spending on the warehouse standing idle for the end customer to use it. So in this analysis, we'll be able to check points like your productivity, your operators productivity, your machines productivity, critical machines, how are we using, are they utilized 100% in the shop floor, and your space utilization, the space that we are planning for the plant, is it enough to carry out the number of products that we want to manufacture? How is our whole plant utilization, OEE, you see, operational effectiveness, they say, overall equipment effectiveness of your whole plant. So this is to validate on a whole plant level, complete plant level, what kind of resource have we deployed, what is the utilization of each and every resource, and how are we going to optimize the resource. So that simulation is, these are also, there are also many tools available. This particular tool, what have been shown in this video, is Technomatics Siemens plant sim. So if you see, this is the whole shop floor layout. They have one area, it's not a whole plant, they have taken one area of the conveyor where the part enters from this side, from the pallet, and it moves, and there are some manual station, there are some automatic station. It crosses all the stations and it comes back, gets assembled, and there is a test station also. Maybe a portion of it will go to the test, remaining will go directly to the final assembly, and from there it goes out to the final. So this whole system is modeled, and whatever small icons you see, you can give your shift calendar, how your factory is going to run, number of workers you can assign, and energy parameters reading you can do. And these are all small graphs you are seeing are all the outcomes. I think in this video he would have shown how it runs. So they have built the plant, built the model, and if you see, he's showing one example. So in this machine, you'll be able to give a setup time, you will be able to give recovery time, cycle time, all your process times, and you can give what are the further stations, how we should behave, uh, where it should supply next, what's the next station subsequent to this station. All these data can be given into a model. For each and every machine, we'll fill this data, and once you are ready with the model, you can write all the logics also, priority logics. This is how the model will run. So you can quickly run it for a whole 1 day and see how much utilization you have taken out of each of the worker or the machine that we are having in the plant. So at this end, I think he has run the simulation for 1 day. One whole day has been run already. You can see the one here. So at the end of 1 day, we'll be able to see what is the utilization of each resource inside the plant. This is his shift calendar. This is the utilization graph. If you can, he can, I think he'll run it again and show it. You can, in the real time, live, you can see how much utilization is being done on each machine. How much are we utilizing each machine? What is the working time? What is the setup time? How much time the machine is waiting for other product? How much time the machine is blocked by the next machine? How much time it has failed? You will also put data like MTBF, MTTR, mean time between failures and mean time to repair. So it will run as if my real plant runs in the real world. So if in my experience in past few years with this software, I have seen almost 90% correlation between the software and the real-time plant. If my software says I'll be able to make 10,000 pieces, at least it will definitely make 9,000. There will be some hits and misses here and there. 90-95% of the software's output and the real plant will match. So what's the advantage of this? Before even I build the plant, in most of the Japanese the car making factories, what I did for the 80 plants that I did, this analysis will be done before the product launch. Before even they think about building the line, they will ask our team to do this analysis and report them on if there are any potential issues they are going to see when the factory is being built. So this way we can optimize the factory layout, we can optimize the number of workers, we can optimize the machines that we are going to use in the line. So it will make your investment very much optimal. Before even going to the real world, you can validate digitally. That's a plant simulation actually. So these are all digital simulations that I wanted you to know today. And benefits as such, by doing this, what is the benefit? You might ask, what's the benefit of doing all this? Overall, from my perspective, in the last few years working with automotive off-highway vehicles, we have seen the product development time reduced by 20% by using this kind of tools effectively. We have seen the reduction in DFMA issues by 65% at least by using this validation tools. And we have seen inventory getting reduced in the plant at least by 15%. Utilization of each and every resource, including operator or machine, we have seen it go up by 20%. We have seen space reduction at least to 10% in a factory when cohesively the top management takes this as a project and validates as a whole. These are the kind of advantages that OEM can. So inventory reduction 15% may seem very less for us on a quicker glance, but hundreds of crores of rupees are getting locked up in inventory each year in any company, depending on the size of the company. So in that, if you see 15%, you think about the size that we are saving. that becomes operating capital for the company. Unnecessarily, they are paying the bank interest. All that can be brought down to, we can make the company more effective uh, using the same workforce or same resources that they are having. And I wanted to give a quick overview on smarter. This was not today's aim actually, but till this moment, whatever we were discussing is industry 3.0 only, using uh, digital softwares and tools, using that capability. How are we analyzing and optimizing a factory? Till this moment, we have not connected anything one to each other. Now, at this juncture, the whole world is moving towards that. There are a lot of sensors coming into the market that are capturing real-time data into the plant, what is happening, and that data can be moved to a server, and a real-time dashboard can be seen by the management at any given point of time. So whatever input in the plant simulation or any other simulation you were seeing, till this moment it was from the customer. The customer says, my this machine takes 1 minute, this machine takes 2 minutes, was the input from the customer till now in an Excel sheet. But now what can happen is, you can take the real input live in the plant and feed that into the simulation model real time, make the simulation model work, tell the simulation let the simulation model tell us where the issue is, and do the corrective action in the real plant online. Day to day, if you start to do this, the factory slowly becomes a smart factory. So whatever tools I have shown you in the previous slides are building blocks for a industry 4.0 smart factory. So if you see, these are the areas our simulation will be working: monitoring the production flow in real time, eliminating the waste, and reducing the in-process inventory. So there will be a simulation model we will be already developing and having it in hand. The real-time data can be fed into the simulation model. The simulation model can suggest us how much inventory should we hold for this condition of the current condition of the factory. Similarly, the simulation model can trigger the right forklift to go into the right location. Most of the time, the simulation, whenever we plan to implement, that's a question most of the time we ask. The simulation model automatically assigns a forklift, shortest path that is available. Model will easily assign that forklift to that particular station. But generally, the plant manager will ask me, so your model is assigning automatically forklift 2 to station number 4. But how will in the real time I will know my forklift 2 is nearby or not, or forklift 3 is nearby? What will happen? So that question can be solved using this industry 4.0. So in future, using the simulation tools and combining the power of all the real-time data and sensors, we are looking forward to see a factory automatic taking its own decision, running effectively, and saving lot of resources. That's all I had for today's discussion to discuss with you. And again, I am reiterating you, all these are, each of the slide we can discuss for 1 week, 1 month, kind of that. That's the size of area that is available in the market. What I have tried to do is, in this available few minutes, I have tried to give an overview idea of what is happening in the digital side of manufacturing engineering. Now I am open for questions and discussions.
Thank you, sir. Thank you very much, sir. It was a knowledge-provoking session, gaining more from the manufacturing engineering. I am sure the knowledge transformed will have a boosting, enriched, innovative idea for all the needful participants. Thank you very much, sir. Sir, we have few questions in the chat box.
Yeah, one second.
What is physical ergonomic? How we can evaluate ergonomic on the workplace?
Yeah, ergonomics is, for example, if a human being is working on a station, how much are we making him to bend, or how much, what is the posture are we giving him? When a human being is interacting with the machine or a station, that's where your ergonomics comes into play. So that analysis is called ergonomic analysis. So if a chair, if I say it's ergonomically good, which means it is comfortable for me to sit. The height of the chair is right so that my foot rests properly in the floor and my back support is proper. So design wise, this is ergonomically good. Similarly, your process also, you have to design ergonomically. Your process should allow the operator to work without stress. It should not give an awkward 20-degree bend always for 8 hours. If somebody, we ask them to bend in 20-degree and keep on working on a particular posture, when there is a break, when he stands up, he's prone to get a backache as soon as possible. So when we design the workstation also, we have to consider the same. As such, you are designing a chair or you are designing your bike, the bike and car, wherever there is a product design ergonomics. Similarly, the line design ergonomics also will function. It should enable the human being to work without stress.
Thank you, sir. There is one more question, sir. To get work in this field, what should I choose after BE? What should be my career? Where should I start working? This is a question from one student, I think.
Okay, so BE is enough. That is, I don't think there are some certification courses specifically on ergonomic design and other things. Maybe we can give a quick overview on what kind of certifications are available. But most of the times, in any tech service industry, if they are into manufacturing engineering services, if you come to know a technology service industry is working on a manufacturing engineering services, and if you come to know there are digital tools available, they are validating this kind of projects. All these projects, what I was telling you, will be there in that company. So we may have to locate the right manager and the right team there to work on. You will be getting exposed to all these. All these software will be available in any tech service company nowadays. Anybody who is there. So there is no additional. After BE, there is nothing being done. I am a BE engineer. I have been working in this field for about 16, 17 years. I have been inducted to all these kind of software. So I think BE is enough because in BE you will anyway understand the basics. Now you would have studied all this in the basics only. Now what you will see in the factory is the application. In the office is the application of all these concepts you studied in engineering.
Okay, sir. Thank you, sir. Thank you very much. Thank you very much, sir. So now I request Dr. Sivagami Madam, Department of Mechanical Engineering, to deliver the oath of thanks.
Yes, ma'am. Good evening to all. It is my privilege to have been a vote of thanks on this occasion. I would like to give a special thanks to Mr. Sundar Narayanan for inspiring us. I especially liked Mr. Sundar Narayanan's speech. The way he explained the topic is exemplary. Thank you, sir. Thank you very much.
Thank you.
I also wish I express my gratitude to our chairman, vice chairman, principal, and director for providing encouragement and support. I heartily thank to my HOD and convener to organize this webinar, as no program can become successful with a single person. So I extend my big thanks to our staff members, students, and the participants from various colleges. Thank you all for making this event successful with your contribution. Thank you, one and all.
Thank you, madam. Thank you so much. HOD, sir.
Thank you, ma'am. Thank you, sir. Sir, as you said, so one slide is life of the many people. It's very good.
Yeah, that's true. Actually.
Yes, that's true. Okay, thank you for your explaining what is happening in a real scenario. It is needed for you. Thank you so much, sir.
Thank you.
Thank you all. Okay.
Thank you all. Sir, shall we